Hello friends. So today's question. The system is pushed by a force F as shown in figure. All surfaces are smooth except between B and C. Friction coefficient between B and C is mu. Find the minimum value of force F to prevent block B from downward slipping is. So this is a system A, B and C, and force F is being applied on them. So we have to find out the value of force F such that the block B does not slip in the downward direction, in this direction. Okay. So first of all, let's draw all the forces that will be acting on the respective blocks. Okay. So this is our block A. Okay, and let us draw. This is our A, B, and this will be the C. So force F is being applied on block A. And its weight is given, mass is given as 2m. So there will be 2 mg in downward direction and normal. Let us suppose that is Na acting in upward direction. Then because of the interaction of the block A and block B, let us suppose there is a N1 here and equal and opposite N will be acting on B also, and there will be a weight that is given as mg, so mg, and it is given that all surfaces are smooth except between B and C. So friction is going to happen between B and C, and if B is moving in the downward direction, let us suppose say Fr is the friction force which is acting on block B, and equal and opposite will be acting on block C. Let us suppose its direction given is this way, Fr, and there will be normal. Let us suppose that is N2 here, between this and this will be N2. Okay. And we are going to have 2 mg on C, and in normal let us call this as NC on block C. So these are the forces, and we assume that one of the basic requirement that B is not going to slip downward if the acceleration of A, B and C is same. Okay, if they are moving in different direction, different acceleration, then obviously B will be moving downward irrespective of the value of the friction. Okay, so first condition is that we can say all three blocks A, B and C should move with same acceleration so that block B remain sandwiched between or we can say remains in contact with A and C and do not fall downwards irrespective of applied force. Okay. this will mean that all the three will be traveling with the same acceleration. Let us say that they are traveling in this direction with the acceleration a. Okay, they are traveling from left to right with the acceleration a. So from here we can say that acceleration of a is small a, acceleration of b is also small a, and acceleration of c is also a. So they are traveling with the same acceleration. Okay. So we can say for all blocks to move with same acceleration a, then we can say that a will equal applied force divided by total mass, that is 2m plus m plus 2m, and from here we can say acceleration is equal to F upon 5m. Okay. So this is the value of the acceleration. Now we are only interested in, because the frictional force is only between B and C, so we are going to find out what will be the normal between B and C, and respectively find out the value of the friction Fr. You can say the normal between B and C, which is given as N2, and N2 is nothing but a type of force. Okay? So we can say that N2 will be equal to mass into acceleration, and mass is our 2m and acceleration is our a, and we can say 2m, value of a is F upon 5, m goes with m. So from here we can say that our N2 is equal to 2 upon 5 multiplied by F. So this is normal reaction between B and C. Next, we can say that block B will try to fall down in the downward direction because of this mg force. And if Fr is able to balance or is greater than mg, then this block B will not be falling in downward direction. So we can say that, write it as block B will not be slipping in downward direction if frictional force is greater than weight of block greater than or equal to weight of block B. So we can write it that if Fr is greater than equal to, weight is given as mg. We already know value of Fr. Our Fr, we can say Fr is equal to mu into N2. This will be mu 2 by 5F. So you substitute value of Fr here, we get 2 upon 5 mu F is greater than equal to mg. And from here we can say that F should be greater than equal to 5 upon 2 mu mg. So we are required to find a minimum value. Okay. So you can say that the minimum value of force F to prevent block B from slipping in downward direction is F minimum is equal to 5 upon 2 mu mg. So this is the minimum value of the force which prevents block P from slipping in the downward direction. Thank you.